Good day, everyone. Welcome to another session of learning. Today, we will discuss all about elasticity of materials. And at the end of our lesson, you are expected to explain Hooke's law using graphical representation between deformation and applied force, and identify the parts of the material that experiences deformation. Last week, we discussed about Hooke's law, which explains that when force is applied towards an object, it can change its shape. And this change in shape due to the application of force is known as deformation. So even very small forces are known to cause some deformation. If you apply too much force to an elastic material, like what you are seeing now, it will lose its elasticity and the material will be deformed. This will happen when the elastic limit of the material is already reached. Now we know that when force is applied to a material, it will be either stretches or compresses in response to the applied force. So that will be the focus of our lesson today, which will be all about stress and strain that will possibly make object deformation. In the field of mechanics, stress is known as the force applied per unit area and is denoted by this symbol, while the strain is the extent to which the material compresses or stretches. Remember that different materials respond differently to applied stress. This information is very necessary for engineers in selecting materials for their structures. So in this lesson, we will look at these properties of solid in greater detail. We'll see how quantities like stress and strain can help us guess the strength of solid. Like what I said a while ago, stress is the force applied per unit area. So mathematically speaking, stress is expressed as stress is equals to force divided by area. The symbol of stress is read as Pascal. In its mathematical expression, Pascal is the symbol of stress, while F is the force and A is the area. The standard unit of stress is Newton per meter square, because the force has a unit of Newton while the area is meter square. Always remember that area is the product of length and width of an object. What happened to stress if the force applied on an object increase? The answer is the stress will increase also. As we can see on its mathematical expression, stress is directly proportional to the force applied. Therefore, if we double the force that is applied on an object, the stress will double also. So what will happen if we increase the area of the object? The stress will decrease. Because in its formula, area is inversely proportional to the stress. Therefore, if we double the area, the stress will decrease or lessen towards an object. Let's now move on to strain. As we discussed, object under strain will change the shape or it will deform. And that change of shape or deformation of object is called as strain. So strain is the extent to which the material compresses or stretches. So it means that it is a change in elongation. That's why we can see a triangle sign read as delta in the mathematical expression denotating the change. So the mathematical expression of strain is equals to change in elongation divided by original length. Remember, both of change in elongation and original length is expressed in meters, while the strain is in epsilon symbol. There are two factors affecting the strain of the object. First is the force applied, and the second is the material. The more force that we apply towards an object, it has a more impact for the strain. While the harder the object, there will be less strain. In line with that, the poor quality of material, the more tendency for the strain. There are actually different types of stress. First is the tensile stress. It happens when the force is applied, resulting in increase of length or area of a body. So objects under the tensile stress becomes thinner and longer. Second is the opposite of tensile stress, which is called as compressive stress. In here, the force applied per unit area resulting in the decrease of length of area or body. The object under compressive stress becomes thinner and shorter. The third is the shear stress. In the shear stress, the force acts parallel to the surface, so it can cause one object to slide over another. The fourth is the bending stress. The bending stress is simply the combination of the compression and tensile stress. And lastly is what we call the torsional or the twisting stress. This stress is produced when we apply the twisting force. So, we can say that stress and strain is important because it provides valuable information about how much force a material can withstand before permanent deformation or failure occurs. So that's all for today. I hope that you learned something from our lesson. You may now proceed in answering activities and your module.